Honor students, this is the Unit 4, Day 3 lecture. You are watching this after you finished your in-class quiz. You should have your handouts in front of you, a pencil, and a red pen. This is your warm-up page. It should take you about 5 minutes. It is your job. Do this on your own. Pause the video, then hit play when finished. I like you to correct in red pen. Do not copy. Pause the video and complete. Welcome back, students. With red pen in hand, let's correct your work. Those two triangles congruent, and number 1, answers in your blank should be angle B and EF. 2, distance is root 17. 3, the reason why the lines are parallel is the converse of the alternate interior angle theorem. In other words, because you have opposites of the Z, then the lines must therefore be parallel. The methods you can use to prove triangles are congruent are side, 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 angle, side, angle, angle, side, and hypoleg, which is used for right triangles only. We're going to recap what we learned last class. So step 1 is no naked diagram. So let's see what we're given here. We are given the fact that AC and AD are congruent. Cross that out. BD bisects CAD. That implies that means these two angles are congruent. So far what we have here is we have ourselves a pair of sides and we have ourselves a pair of angles. We're walking ourselves through given, imply, freebies, talk it through. Now, freebies, remember the sources of freebies? Sources of freebies are vertical angles and reflexive sides, and right down the middle here, we have a reflexive side. So you can see right now that your punchline for these two triangles to be congruent is side, angle, side. Your job is this. The statements and reasons have been scrambled. You are going to order both the statements on the left and the reasons on the right. Then you're going to answer this question, that if the triangles are congruent, what other parts must therefore be congruent? At this point, you're going to pause the video, do not copy, switch to a red pen to check your work, pause. Welcome back. You should have a red pen in hand. Let's take a look here of what you have. There is your correct statements, and the reasons are in parentheses. Check your work. If you're correct in red pen, I expect to see stuff like this. Oh, I got that one right. I got that one right. Oh, that's great. That's great. Something like that. If you got something wrong, I expect a note. What are you going to remember next time? The parts that are congruent, because the triangles are equal, the other segments are congruent as well as the other two angles. Let's recap this last class. This is very important abbreviation, C, P, C, T, C. Stands for corresponding parts. Congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. The basic premise is if a whole is congruent, and I mean by whole in the next problem is because the whole triangles are congruent. If you can prove that the whole triangle is congruent, then the parts are congruent. The parts would be segments are congruent to segments, or angles are congruent to angles. So the simple concept is if the whole triangles are equal, then all the other parts of the triangles are equal. That's C, D, C, T, C. We're going to do an example here. So we take a look. Notice I don't have the diagrams showing yet because I want you to show mark on the diagram. These two segments are equal. AD, trace it, and CD. We have ourselves a pair of sides. Mark this with me. AD is also congruent to CD. Gives us another pair of sides. Of course, then you have a reflexive down the middle side. But we can already see that the triangles, the whole triangles are congruent by side, side, side. We're trying to prove, remember prove just means explain, how you can get angle A and angle C congruent. Well, if the whole is congruent, then the parts are congruent. And that's what this is saying here. Take a look, let's look at the proof here. That given, that was your first pair of sides. And that one was another pair of sides. Then we have the reflexive side. And the reasons are there. That gives us the triangles are congruent by side, side, side. And that would write the word whole here. If the whole is congruent, then the parts are congruent. If the whole is congruent, then the parts are congruent. And that is what we call corresponding parts of congruent triangles are congruent. We're going to do a couple of these proofs kind of together. We're going to first follow gift. Super important. Do not skip this step. Students, I know your tendency is to instantly go for those blanks. Stop it. Get your hands off those blanks. You have to be able to think this through. So you think it through by doing gift. Let's start with what's given. Given angle P and segment PQ and RQ are congruent. So we trace it, hatch mark, side. What's also given angle PQS, this angle, and RQS, this angle are also congruent as pair of angles. Cross it out. Implied and freebies, we usually do that together. We have another reflexive side. You kind of think it through, talk it through. If we can get the entire triangle congruent, then we can hit our target. Whole, and we can get our part congruent. So that's the talk through. If you can get the entire triangles congruent, then you can get the part congruent. Now that you know what we're doing here, let's fill this out. So the first one, is to have a pair of sides. Identify where here we have our A. Why do we know that? It's given. We got our same side, we went left, congruent to F. That's another pair of sides. Reflexive property. So down origin, here we have a side and an angle, and there's another side. And you can now see triangle 2S traces like I did. Is congruent to triangle. I'm going to pause here. I'd like you to put that second triangle in. You have 10 seconds. Just to align the vertices, that'd be R2S. The reason is starting on the side, right toward the hole here. If the hole is congruent, then we can finally say if the hole is congruent, then the hole is congruent, and those two angles right here, P and R, are congruent because their corresponding parts, congruent triangles are congruent, and the margin just right parts congruent. I'd like you to recognize both the fancy term, which you're going to use on Alex, as well as my shortcut slang. Let's try another pair. Once again, do not go for these blanks. Keep your fingers off those blanks, please. Instead, we're going to walk ourselves through given, implied, freebies, talk through. Let's start by marking the given. You're told that triangle UXW and triangle UVW are right triangles. So you're first told that they're right triangles. We're also told that UX is congruent to UV. Because we're dealing with right triangles, we're not going to call those sides. Instead, we're going to call those hypo. There's our given. Implied and freebies go together. What's implied, or technically what's a freebie, is that we have UW congruent to UW because it's a reflexive, and we do not say side here, we say leg. Why am I using the terminology leg? Because it is a right triangle. Now let's talk through. We want to prove that X and V are congruent. Question mark there. If you can get the whole triangle congruent, then you can get the part congruent. So you ask yourself, how can you get the whole triangle congruent? It's pretty much spelled out for you if you look very carefully. We already have a pair of hypos, and then we have the leg. So the whole triangle is congruent by HL. Now we can fill out our proof. Number one, those triangles are right triangles. Why do we know that? It is given. Number two, UX and UV, which is for hypo. Why do we know that's true? That's given. Look very carefully. UW is congruent to UW. It looks exactly the same, just like it looks the same. That would be reflexive property. Write the word egg. So I have an H and an L, which tells me my triangles are congruent. Watch very carefully. I'm going to go like this. Triangle X, UW. I'd like you to write in the matching triangle on the other side. 10 seconds. You should have V, UW. And the reason here is hypo leg. Remember, you cannot use here side-side angle, because remember, side-side angle is the ambiguous case. The only time it seems to work is in right triangles, and because that's a very unique situation, we don't even call it side-side angle. We call it hypoleg. Write the word whole congruent. And if the whole is congruent, then the parts are congruent, which are the two angles that you're trying to prove. Corresponding parts, congruent triangles are congruent. Whole congruent, parts congruent. Super important as you do these proofs on your own. All your thinking is done on the diagrams. Only that. Then you do your proof. No naked diagrams. For this page, step one, what I'd like you to do, please, is point on the grid to the right, and then you're going to do the distance equation 6 times. I want to see the work. You have space on your binder paper. Distance equation 6 times. I'd like you to pause the video, do your work, and then restart. Pause. Okay, students, welcome back. Let's check your distance equation. The length of AB, you should have got 3 units. BC was 5 units. AC was 4 units. XY was 3 units. YZ is 5 units. And X to Z was 4 units. You proved these triangles are congruent by side, side, side. And you did that using the distance equation. Distance shows length. Slope shows slope. That'd be like the issues of perpendicular or parallel. And of course, midpoint shows the middle of things. So keep in mind those 3 types of equations and what you use. How do you know that those angles are equal? Because if the whole is equal, the parts are equal. C, BC, TC. Alrighty. These 3 you're going to do on your own. What are the shortcuts? Pause the video, do your work, get your red pen and check. Pause. Welcome back. Let's check your work. That one's angle, side angle, or the hamburger, if you will, angle, side angle. With HL, Y, right triangles. This one would be side, 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 exit, or side angle, side. Why? Because if you have 2 equal sides, you have 2 equal angles. So it could be side angle side, or because all the way around side side, side, side. Now for the big stuff. I'm going to walk you through this first. No naked diagram. Given, implied, these, talk it through. Given, FAB is congruent to ED. We're also told that ACB is congruent to DC. That gives us within the triangle, that gives us a parallel triangle. And we're also given the fact that AC and EC are congruent. These guys, that gets us a parallel side. As a given. Implied in freebies. There's no freebies here. There's no vertical angle. There's no reflexive sides. But what's implied indirectly congruent. These two inner ones are going to be congruent because they both have a linear pair, which gives us another pair of angles. So you can kind of see the shortcut we're going here for. This is a candidate angle side angle. It is your job now to write a two-column proof. Pause the video, write your two-column proof, then get out a red pen to check. Pause. Welcome back. Students, did you actually do your own work, or are you about to copy right now? If you're about to copy right now, put that pen down, do your own work in pencil, then pick up your red pen to correct. All right, let's check. Let's check your work. So you start with your given, and then we could say our supplements. Now your orders can be slightly different here, so we say they're supplementary. And then that gets us our first pair of angles here in the corner. There's the angles. Then you had your other angle here and your sandwich side. I put those in one step. You can break that down into 2 steps. It's perfectly fine. And then the triangles are congruent by angle side angle. Okay, so this one, let's take a look at what we're given, implied, freebies, talk through. Given, implied, freebies, talk it through. Given, PQR is isosceles with QR as the base. That implies we have 2 equal sides. We also are given the fact that PA and PB are congruent. Our goal is to show that AR is congruent to PQ. Now, do you see you have overlapping triangles? This is the tricky part. Whenever you have overlapping triangles, the first thing you should do is you should pull them apart. It is a lot easier to work with these if you pull them apart. Okay, so our goal is to get these triangles congruent. And if the whole triangle is congruent, Write the word whole and the parts are congruent. That's where we're going here. So here's your triangles that you're trying to get congruent. Now they are pulled apart. A, Q, R, B, Q, R. So now with the pulled apart triangles, because this squiggle is given, and because you have isosceles, if the two equal sides are equal, then these base angles are equal. That would be angle Q is congruent to angle R. So immediately we have a pair of angles. Going to take a couple steps, but if PA and PB are equal, then by segment subtraction, you could say QA is congruent to BR. That takes at least 2 steps. That gets us a pair of sides. Then implied, look, we have QR and QR. Do you see how QR is actually shared in the original? That gets you another pair of sides. So I can see right now that these triangles will be congruent by side, angle, side. And if my whole triangles are congruent, then my parts are congruent that we're trying to get, which are these guys. Okay, this is a multi-step proof, folks. Do the best you can to ferret out how this is going to work. Pause the video. Restart with a red pen in hand. Welcome back. So right here, let's check this out. Here we know that PQ and PR are congruent. There's your given. Your last one here. As far as the proof is concerned, take a look. It says X is the midpoint of AC. So your first given, if it's a midpoint, we know A to X is congruent to here. And then we're told that angles 1 and 2 are congruent. Trying to prove that X is a midpoint of ED. And the way we want to do that, it just takes 2 steps. Before you first say that dx is congruent to xb. That's a prior step. And that's a part congruent. Before you can even say that, we first have to say that the triangles are congruent. So if we can get these triangles congruent, I'm going to highlight them for you. If you can get these 2 triangles congruent, then you can say your parts are congruent. And if those parts are congruent, then you can say it's a midpoint. So your goal is to figure out how to get those yellow triangles congruent and write yourself a proof. Pause the video, do your own work, then recheck. Welcome back. Check your work. What you got here was the fact that your vertical angles was the key here. That gets you an angle. There's a side, another angle. So the triangles are congruent by angle, side, angle. That was the yellow triangles in the high. And if the triangles are congruent, then those red segments are congruent. And if those red segments are congruent, then lo and behold, you have yourself a midpoint. Last one, I'd like you to plot all those points. And I'd like you to use that distance equation and find the distance of all sides. So I need to see the distance equation 6 times. Here's your template for the distance equation. I should see your distance equation 6 times, 3 for each triangle. Show your work, and then your goal is to prove that those triangles are congruent. I want a summary underneath. How does your math show the distance equation 6 times? How does your math prove that the triangles are congruent? Pause the video, do your own work, then restart. Welcome back. Let's check your work. You should have noticed that 2 side lengths matched at root 13. 2 other side lengths matched at root 13. The last 2 third pair match at 4. Therefore, it's congruent by side, side, side. Students, you should have evidence of corrections on your papers. If you do and you are finished, go see your teacher for a sign-off.